Hi, welcome. You're here with Mr. Canada, and we're going to look at estimating powers. Estimating powers comes in handy. Well, when you're on the real world, we estimate things all the time. You're trying to buy something for your kitchen. You got to estimate the size, estimate the materials, estimate how much you're going to spend when you remodel, things like these, right? So it can help, when we're doing, say, how much stuff can fit into a house. Well, we talk about that in cubic feet or cubic inches or cubic meters, right? That's why we can use some estimation in terms of cubes, squares. We can estimate the carpet size of our floor, so on and so forth. So we want to be able to make reasonable representations for this. So the way we do this, if we look at example 1, we have 4.3 squared. So we want to find out what if we have a number line and we have the value 4 and 5, and here's 4.3, right? We want to find the square of 4 and of 5. So the numbers that are sandwiched between. Okay? So here, I'm going to say 4 squared is equal to 16, and we know 5 squared is equal to 25. So that means I know that my value is really between 16 and 25. We said, so that 4 is there, that 5 is to there, and we know that this 4.3 was kind of over here, right? So, if you notice, step 2 is the estimate will lie between these two values. So, and I kind of knew where I was going. It's weighted closer to here. So, easiest is, well, what's halfway between 25 and 16? Well, we just have to subtract the 2 and divide, right? So this is 9 difference. So in between, that means if we add or subtract 9 halves, which is 4.5, we will find our midpoint. So here at 20.5 is our midpoint. So I'm going to give a pretty good estimate of 4.3 as, let's say, 19, right? So, because it's not going to be 20, right? And it's not going to be 17 because it's too much bigger than that. 4.3, it's not 4. So a reasonable estimate is just kind of a little bit smaller, is going to be 18. Okay. Now, at this point, I want you to take out your calculators and try and do 4.3 squared. Right? So the actual value was, so the actual is 18.49. So that's relatively close for a guess, right? That's what we want. We want something relatively close. Okay? So same thing here, 2.7 and 4. So we're going to do, 2 and 3. So we're going to get 4 and 9. Halfway between, if I add 1, I have 5. I have 6, 7, 8. And here we can say 0.2, 0.4, 0.6, 0.8. That's not exactly how it always works out, but I'm just going to give a pretty good estimate, right? So if I know that, hey, I'm looking for somewhere around here, I'm going to say, well, why don't we estimate at 7.5, right? And then so that is just if we square it though, right? So make sure you read the question and you see that this is to the power 4. Right? So if you think it might be really easy, sometimes look, right? So keep in mind that estimating only worked for that. So if it's to the power 4, you got to treat it as such. Okay, so to the power 4, so 2 to the power 4, 2 times 2 is 4, times 2 is 8, so we have 16. And our other value, 3 times 3 is 9, times 3 is 27, times 3 is 81. So this is a little bit harder. Our estimates can be not as good because we're pretty far off. Actually, I'm going to draw a better straight line. So if we know at the one side we have 81, if we know at this side we have 16, and we're looking for a value of 2.7, well, that's half. So if we want to find that, we have to find 81 minus 16, which is equal to 65, right? Divide that in half. So that is 32.5, right? So that means this halfway is going to be at 48.5, right? And we're about halfway in between those, I'd say. So I'm just going to do 81 minus 41.5 to figure out what I think it might be half, right? So this is, and then I'm going to have the answer, because and I'll have to add it back on or subtract it off my 81. So same thing, I'm just doing another kind of getting closer, because I think 0.7 is about halfway between that, right? So this is if you want to kind of go as accurate as you can, just start breaking up into chunks. So this gets us 81 minus 1 is 80, minus 40.5 is 39.5, 39.5 divided by 2 is 19.75, right? So that means if we go 19.75, add that on to our 48.5, that's going to be my estimate. This one's a little bit more convoluted. So that's 20.25, 28.25, 68.25 is my estimate. Like I said, this more convoluted. You don't exactly. I like being as accurate as I can, right? You could always take a guess, right? But it's a little bit harder to guess when your numbers are a lot bigger, so I like doing a second round. So here, let's check it. 2.7 times 2.7 times 2.7 times 2.7. Well, we got 53.14. So not as good as we had originally thought, but so here we have an estimate of something with a negative, right? So what are we going to do? Well, we know that 3 to the power 3 is equal to 27, and then we have 4 to the power 3, which is 64. So we have 1 over 27, then 1 over 27, and 1 over 64. So this one's a little bit less fun because we have to get these into decimals. So if we convert these to decimals quickly, I'm not going through the actual converting it to decimals because that's something you should be responsible for. So I'm just focusing on giving you the numbers so we can work with them. Okay. So, and then 1 over 64, that was 0.15625. So same idea is going to happen. I did state the first one is recurring, but it doesn't really matter. We're just going to subtract these two, right? And we'll find that their difference is negative 0. Oh, sorry. I subtracted the wrong one. It is 0.021412. And let's have this. Right, so we can add that on to our either one. So an estimate that I'm going to give is my estimate is going to be 0.146. Okay, I'm just going to leave it to 3 decimals because it doesn't ask us. So we can do that. We can do 3. Let's check this. 3.6 times 3.6 times 3.6. And 1 divided by 46.6. So it got 0.02. So our estimate wasn't as accurate as we had hoped. So keep in mind, just try and be as accurate as you can. So try these ones. When you're ready, press play, and we'll go through the answers. Alright, so welcome back. I've done a little bit of work myself and kind of put what the lower and upper indices would be after the power is applied, and then find the middle. Okay, so that's just a little bit of tedious process that we do for each one. So then we make a fair judgment off this. So this 0.3 is less than half, right? So I'm going to say, well, it's kind of in between these two. I'm going to say my estimate is 5. Okay. Here, 170 was halfway, and I know I'm bigger than 170, so I'm going to say it's about 190, right? So you can tell that some estimates are going to be better. We'll go through what the actual answers are after, just to see how we're close we are, right? So it's good to see if we are thinking of this in a good way, or, well, are we totally out to lunch? So here, our middle was 633.5. So that actually is what I'm going to take, is 633.5, and see how well that works out, because that one just ended in 0.5. Here, with just a little bit less, so I'm going to say, let's say 40, right? Just trying to get a rough idea. Here, it's going to be closer, right, to the one end than the other. So keep in mind that when you do fractions, they are a little bit confusing and a little bit less accurate in my mind because we work with such small decimals. So we know that we're going to be about halfway, so I'm going to put 0.0135. And lastly, to the negative 4, so I am going to put it at 0.5, or let's do maybe 0.3, okay? And we'll try that. So I will be back in 1 second. I'll put up your answers. Alright, so if you can tell, I put the estimates, or the actual answers here in blue. I kind of rounded off with some of them because it didn't really matter much. The first one, pretty accurate, right? So 5.29. Second one, I'd say that's really good considering the vastness of our numbers. So we're only plus or minus 5. The next one, a little bit further off, but considering how big of a spread from 243 to 1024, guessing that that was 525 is actually not terrible. 4, however, really good estimate, right? So 40.9 and 40, right? Next one, pretty good for being a fractional or a negative index. And then the last one, didn't do as well with that one, but like I said, sometimes harder when you're going from 1 and then you're going like 2 place values away to a 0.0 of a value.